here they're giving us the magnitude and the direction of the vectors. They want us to write the vector in component form, which means the two numbers separated by a comma inside the vector brackets. So since it's giving us the magnitude being 4 and the direction being 45 degrees, you have to kind of think of what that means. It means, like, if I was drawing a quick picture of this, I know I showed it ahead of time already, but just to... If I drew a quick picture of this, it means, okay, well, if I get it to draw, there we go. I'm off in this direction here and have a magnitude of 4. Well, how am I going to come up with the actual vector component? I mean, I need to come up with what this is up here. I get to do it. This dot right up here. There we go. So I need to find that location. So... But it kind of relates back to what we discussed before with rotations and, like, radius of rotations and things like that. Same kind of deal here. Here's my theta, 40, in this case it's 45 degrees. So it's like, okay, well, how am I going to come up with an x and y movement to represent that, with this being given a magnitude of 4? Well, that comes from me using my definition of trig functions again. And it kind of boils down to, like, how do we find... polar coordinates to rectangular coordinates. It's the same kind of instance here, because I'm going from a magnitude and a direction to actually having two numbers that describe what the movement, but in terms of horizontal and vertical only, this is. So essentially, if I'm given a magnitude and a direction, all I do is take that magnitude times the cosine of the direction for my first component, and I do 4 times the sine of that direction, or the r times the sine, for my second component. So here it's going to be 4 times the cosine of 45 degrees, comma, 4 times the sine of 45 degrees. Of course, we should know what the cosine and sine of 45 degrees are. It's the square root of 2 over 2, and 4 times, that's going to make 2 times square root 2 for both of them.